Hello everyone, I am Manju Singh Sachan and I will be presenting my lightning talk on the topic hand gesture detection using smartwatch. You all must be familiar with gesture detection using smartphones and might also have used it at some point. Gesture detection in smartphones works in two ways. One, where inertial sensors like accelerometer and gyroscope are used to detect gestures and perform actions like flipping down the phone to hang up or picking up the phone to answer a call. Another way gestures are used in smartphones is by using sensors like infrared and radar, where the user performs the gestures in the periphery of the smartphones and tasks are performed without even touching the device. Similar type of sensors are also used in gaming consoles like Xbox Kinect to allow for a more immersive experience while playing video games. In recent years, a lot of research has focused on gesture detection using smartwatches. There are different ways of accomplishing this, which I will discuss in the following few slides. First is the touchscreen-based sensors, which detect gestures which the user performs using differences in touch pressure, duration, and gesture pan. These are perhaps the most commonly available in commercial smartwatches. Next is detecting fine motor finger movements with the help of inertial sensors like accelerometer and gyroscope. Another method is to detect the movement of tendons of fingers passing through the wrist using the same inertial sensors. Some researchers have also combined the data collected from inertial sensors with microphone data to detect on-skin gestures like taps and slides. Similar sensors can be used to detect gestures on the body of the smartwatch, where the user can tap on the case, bezel, or the band of the watch. Bioacoustic signals can also be utilized to sense gestures like flicks, claps, and scratches. Sensing of these signals requires a more enhanced kernel, which boosts the sampling rate of the smartwatch's existing accelerometer. One study also utilized electrical impedance tomography technique using electrodes residing in the watch's wristband to measure cross-sectional impedances on the user's arm. These various techniques of gesture detection using smartwatches have wide-ranging applications. The application that I am most interested in is ASL detection. I believe using a combination of inertial sensors, we should be able to sense different signs of ASL. I hope you found this topic as interesting as I did. Thank you for listening.